Hi students, welcome back. Let's continue with the classification of the ad hoc wireless network protocols over TCP. So far we had seen about the different TCP over ad hoc wireless network protocols like TCP-F, that is a feedback TCP, TCP-ELFN and the TCP bus. And coming to the next protocol, that is the ad hoc TCP. Actually, these are all the end-to-end approach wireless network protocols. Now coming to the next protocol, that is ad hoc TCP. Based on the feedback information received from the intermediate nodes, the TCP sender changes its states to persist state, congestion control state and the retransmission state. Okay, so what they are saying here, the sender was there and the receiver was there. Based on the feedback information received from the intermediate node, so in between some intermediate nodes are there, a communication will be established based on the intermediate nodes. Okay, so here based on that feedback information given by this intermediate node, the TCP sender, so this is a TCP sender, the TCP sender changes its states to either it is a persistent state or the congestion control state or a retransmission state. Why this sender is changing this state to different types of state? Because if the receiver doesn't receive the packet, if the packet is lost in the intermediate node, okay, so the intermediate node will intimate to the sender that the packet was lost. The packet is didn't received by the receiver. So whenever the sender receives that information, the sender may enter into the persistent state or the congestion control state or the retransmission state. So when an intermediate node finds that the network is partitioned, then the TCP sender state is changed to the persistent state, then it where it avoids unnecessary retransmission. So when the TCP sender will enter into the persistent state. So whenever the intermediate node finds that the network is partitioned, then the TCP sender, so network is partitioned means suppose different routes are there. Suppose the packet is the route was broken in this path. So the intermediate node will send the packet to by taking the another route. So in that cases, the sender is no need to retransmit the packet. Why the sender is no need to retransmit the packet? Because the intermediate node is already sent the packet to the receiver by taking the another route. Okay, so in that case, the sender will enter into the persistent state. So let us see the diagram, the thin layer implementation of ad hoc transport TCP layer between the traditional TCP layer and the IP layer. So you already know that IP layer is present in the network layer. This is a lower layer. This does not require the changes in the existing TCP protocol, and this layer is active only at the TCP sender. That the thin layer will be active. The ad hoc transport control protocol layer will be active only at the TCP layer. So see this diagram. This is ad hoc TCP thin layer implementation. So you're having the TCP layer in by network layer and the data link layer, that is a MAC layer, and the physical layer. Okay, so these are all the lower layers. So here first a data will be sent to the, let's take the data is from here, from physical layer to the network layer. So this is a input IP input. Okay, so the IP input will be stored in the network. So this network will send the packet to TCP. In between the TCP layer and the network layer, there is another layer, that is a ATCP. Means it's a thin layer implementation, just a thin layer implementation. So this ad hoc transport control protocol, it's a wireless network. It's a wireless. Okay, so this is a thin layer which is present in between the TCP and the network layer. Okay, so the input data will be IP packet will be sent to the ATCP. The ATCP will send to the TCP input. So now here this is the input, and the data output from the above layers, means above the TCP there is a session layer, physical layer, application layer will be there. So the data will be sent to the TCP, and the TCP will send the data to the thin layer, that is the ATCP output, which is a wireless protocol, and again that will be sent to the input OP, that is a network layer. So this is how the ATCP thin layer implementation will be established. So the ad hoc TCP will act as a thin layer in between the TCP and the network layer. So see here the state transmission diagram for ATCP sender. So here there are states are there. One is the loss state and the congested state, a normal state, and the disconnection state. So there are three states that are present in the state transition diagram of ATCP. Okay, so this is a normal state. So if suppose any packet is lost, the ATCP retransmission segment in ITCP buffer, so whenever it is lost, an acknowledgement will be sent. Okay, and suppose a normal state will send a duplicate acknowledgement before RTO, or it sends a 3 duplicate acknowledgements. So whenever the 3 duplicate acknowledgements are received, it enter into the lost state, means there is a packet is lost, that's why we are getting the duplicate acknowledgement. So when it is a congested, so whenever it is receives the BCN, enter into the congested state. So after the congestion is over, it transmits the packet. TCP transmission packet will be sent to the normal state. So whenever this state will receive the TCP transmission packet, it performs the operation and sends the DUR, receive destination unreachable. Okay, so when it sends the receive destination unreachable, whenever the duplicate acknowledgement packet is received, it sends the receive destination unreachable. So whenever it receives the receive destination unreachable, it enter into the disconnection state. Okay, so when all the states or sends the DUR packets, that is a receive destination unreachable state, the sender is going to enter into the disconnection state. Okay, so the sender may be in disconnection state, normal state, lost state, or in the congestion state. So the major functions of the ad hoc transport control protocol layer is that it monitors the packets sent and received by the TCP sender. So that is the one function. And the function is the state of TCP sender and the state of the network layer. So these are the major functions of the ATCP layer has to perform, that has to monitor. So the packet is sent and received by the TCP sender, the state of the TCP sender, and the state of the network. The state transmission diagram, whatever I just shown you, here you are having the 4 states: normal state, congested state, lost state, and the disconnection state. When TCP connection is established, the ad hoc transport control protocol sender state is in normal. So when it is in normal state, whenever the connection is established, then ATCP sender is in normal state. Here ATCP does not interface with the operation of TCP and it remains invisible. So now let's see the advantages and disadvantages of this ad hoc TCP, which is an end-to-end approach. Advantages are, it maintains the end-to-end semantics of TCP. It is compatible with the traditional TCP, and it also improves the throughput of TCP in ad hoc wireless networks. Then what about the disadvantages? Depending on the network layer protocol to detect the route changes and the partition. So here the dependency will be there on network layer protocol. Why? To detect the route changes and the partitions, the ad hoc TCP has to be dependent on the network layer. Addition of thin ATCP layer to TCP IP protocol stack requires a change in the interface functions currently being used. So obviously we are introduced one of the ATCP layer, which is a thin layer in between the IP protocol and the TCP protocol. So which is here the stack requires the changes in the interface function currently being used. So this is a disadvantage of using the ad hoc transport control protocol. Thank you.